Okay, in this scenario, we will run our automation against a little more complex scenario. We will take up a Kafka publisher class and a Kafka consumer class, and we will see what JUnits get produced by our automation. Let's look at our publisher, Kafka publisher class first. So this one is our Kafka publisher. So you see, this is a standard Kafka publisher which has a publish method. It takes in a customer as an input, and then it does this here. A Kafka customer Kafka template dot send, and then it sends this particular customer object to this particular topic. The complexity that we encounter here is this Kafka template. This Kafka template actually requires in real actually sends the message to an external Kafka topic which exists in an ecosystem of Kafka browsers. So essentially what we are seeing is this kind of test does not really fit very well within unit tests. It is more of an integration test. It becomes very challenging to write unit tests for this kind of scenario, because when we run this unit test, we may or may not have these Kafka brokers and the Kafka topics available to us. So in that case, what happens? Should our test just fail? Let's see what our automation generates for this kind of situation. So what we will do is we will go back to our automation location, that is this app setup, and we will run this. So again, the same steps. This is informational. Give the path of the top level of your test project, and then give the path of your application main class, and then I want to run auto generate. I want to auto generate JUnit, so 1, and here I have to give it the name of my target class. So the target class is my Kafka publisher. So basically package dot name of the class. All right, so give it and then keep going forward. Let it create the necessary environment, prepare the necessary components that it requires to generate the automation components. Right, so it's gathered all the information that it needs. It's moving forward to create the JUnits. Okay, so as expected, it has detected that the target class is neither a controller nor a service, so it wants a confirmation from you that that is indeed the case. Yes, it is neither a REST controller nor a service. It is actually a component and a Kafka producer. So anyways, we will say yes, this is neither a REST controller nor a service. Okay, so it has a basic question for you about this particular target class. There is a method it has found, customer repo.say. What is the return type of this above method? Let's go to this target class and see where it is. What is the return type of this above method? The return type is customer, so we will give it the full path of the customer. Okay, the next question it has is, it has found this array listenable future. Is the above class or Pojo specific to your application? Let's find out. Okay, this one is, it has internally figured that one of the return types here is of type listener. Most likely it is due to this one, here, listenable future, right? And this one generates a listenable future. So it is asking whether this array listenable future is part of our custom application. It is not. It is part of Spring Boot or Java, one of those. Let's see what it is. So listenable future is part of Spring Boot, Spring Framework. So since it is not part of our class of our application, we will say a no. Okay, so now it has, based on just basic inputs, it has generated the JUnits, and now we will go back to our main console to run the next steps. This is our main console. Code processing is complete, so we will hit the next button and then move to this page. Your JUnits are generated and saved at the below location. Please review. So we go to this location and check what it has generated for us. Yeah, so you see this, it has generated this customer transaction publisher type 1 test for us. Let's review it to see whether are there any compilation errors or anything that looks out of the place on this one. I've refreshed the application and then I am opening this. So this is a test that it generated for us, customer. So you see there are no compilation errors. So first step, it looks good. Let's look at the method that it's generated. This is the method, test method that it generated corresponding to publish. Our method, invocation method is publish. It takes in a customer input. So this is the corresponding test method it generated. Okay, so in this, the invocation is done to this one. Okay, the invocation is done here. Okay, customer transaction publisher type 1 and publish. See, what happens is that when you call this publish method, one thing is that it is making a call to an external class which is cust repo, and it is saving the customer. This external class needs to be first stubbed and mocked. So for that, it has created this particular mocking. When customer.save is called, return this particular stubbed customer back. All right. It also says that there is also another external instance, that is customer Kafka template, which is of type Kafka template. When customer Kafka template.send is invoked, what does it? How do we mock that? So that is mocked by saying that when customer template.send is invoked, then return a response future, and response future is defined here. It's just declared here as a mock bean. Okay. So what happens is that the challenge occurs here. This kind of test cannot be done with the regular JUnit. You cannot just invoke this and expect a result to come and then check the output of check that particular output, because when we say publish, it hits this template, and when it hits this customer template.send, it actually sends the message to the broker and to the Kafka topic. So this kind of class requires those external structures to be in place, and we may not always have that kind of availability when running this these JUnits. These may be running on our pipelines and other environments like dev environments or so, where we may not have this running access to this infrastructure. Even our local, when you run this test in your local, you may not have access to that particular topic, or let's say the UAT topic, or say staging topic, or dev topics. So what do we do in that case? So what this automation does is it hits a publish, okay, and it checks if it actually let's say happy path scenario that the particular topic or the brokers are available. If so, then it will execute that, and it will come down to this line here, and it will return a success. And if it returns a success, then we are simply verifying that the result is a success, and that's it. That would confirm to us that it is successfully run. But in many cases, this will most likely return a failure. This most likely will return an exception, because that particular Kafka topic and broker will not be available. If so, then it comes here. How do we verify that the actual invocation happened? That means this send was actually invoked. In the exception, you see, if the topic and the brokers are not available, you will pretty much get a timeout exception. And if that is what we have detected, then that is pretty much a confirmation that yes, our flow went all the way to this point, and then it came back because it could not move forward from this point onwards. But that's a good enough confirmation for us that we actually were able to process all the way up to this point. And there we would indicate this as a success. This is what the automation generates. When it says, when it gets this specific exception, we mark it as a success. That simply means that Kafka send and send operations were actually invoked. Now let's say if there's some other exception other than this happens. Let's say it's a null pointer exception, for example, that happened. In that case, the exception would reach here. That would simply mean our class execution has failed, and that would be marked as a failure. So the verification is done based on that. So assert if result is success, then it is a success. And we also verify that the stub, the repository method save is called exactly once. So this is the publisher test that gets generated by the automation. It's a complex scenario, and hence a corresponding JUnit is generated for this particular scenario. Now we will attempt to, now that there are no compilation errors and all the components are available in the JUnit, we will attempt to run launch auto generated JUnits. Yes. So it is launching this particular customer transaction publisher type 1 test. Alright, so what it is doing here is that it has actually invoked the customer Kafka template.send, and it is attempting to send the message to the topic. In this case, the topics are not available, and hence it keeps on trying it for the timeout. For the timeout that we have said is probably 1 minute or so. So it keeps doing that, and you will notice that at one point of time it will give up and say timeout exception. That would indicate to us that it actually made the attempt to invoke the send operation on Kafka, and that to us indicates that it's a successful operation given the constraints of this particular scenario. This is how we verify this particular test. Now this is the coverage report that it generated. Let's go straight to the publisher. We see that the publisher test is generated, see that the coverage that we have got for the publisher, the overall coverage for this class is 38%, and the coverage for our actual method is 28%. So essentially this is what happens. Given the constraints that we have, only this could be actually executed. When it tried to execute this, it failed because we don't have it. Assume that we had this available, then our operation would have actually executed this and this line, and then our coverage would be 100%. But in a scenario like this, where the situation is not exactly a fit for JUnit, it is instead a better fit for integration side. We'll still have made an attempt, a very good and a sincere attempt to add coverage to our code, and we have achieved quite significant results here given the challenge at hand. What we will next do is we will try to run this for the consumer now. Okay, let's see what happens with the consumer. The consumer is here. Again, we will go back to our, let's take a look at the consumer class, how it looks. This is a Kafka consumer. As you would expect, it is a Kafka consumer. It looks for this particular topic, and it grabs messages from that topic. Once it grabs the messages, what it does is it basically does some print, and then it takes in the customer, takes in whatever comes in, and then invokes a delete from the repository. The challenge here is, again, this particular Kafka consumer is absolutely dependent on the external resource, that is the topic. Again, when you are running this test, this particular topic may or may not be available. If it is available, then it will directly get that message, and then it will invoke the next steps. But most of our cases, practically speaking, when you run this particular build, this Kafka topics and brokers will not be available, and hence it will never invoke this particular invocation through this Kafka listener. So the only option that we have to add coverage and to provide certain degree of code coverage and certain degree of checks on our application is to invoke this method directly, and then check whether these operations are actually happening or not. So let's run this one again. The reason we are doing this taking this middle ground is because these type of tests are more suited towards integration tests rather than JUnit tests, but we still want to put some degree of coverage for these kind of tests also as part of our JUnits. Hence we take this particular this approach, this middle ground approach. Okay, having said that, let's run this against our automation. So we go back to our automation directory, which is your app setup. We launch the setup.bat, again the same thing, informational, and we give it the path of our application, top level path. We give it the path of our application class, and then we tell it that auto generate the JUnits. For which class do you want to auto generate the JUnit? I want to auto generate it for this particular Kafka transaction, Kafka consumer. So this dot name of my consumer class, and go for it. So now it will start doing the necessary setup, the preparation work for the automation. So at this point it's trying to determine what kind of class is this, what kind of target class is this. Is it a controller, is it a service class, is it some kind of other component, is it some kind of a repository, etc. It does a lot of deductions based on deducing based on the information that it scans from your classes. And once it does that, then it will start the process of creating the JUnits. So the build is success. Okay, so here this is what asking you for a confirmation. Is this target class of type neither REST controller nor service? Yes, it is neither a REST controller nor service. It is of Kafka. It is a component, and it is a Kafka consumer type. So yes, it's neither a REST controller nor a service. So we put a yes here. So it will move forward now. It will try to figure out what is the pattern of JUnit to be created for this one. Okay, it has found something like delete, and what it wants to know is what is the data type of this input. Let's see where the delete is. Delete. What is the data type of this input argument? The input argument is customer, and the data type of this is customer. So we just have to take this one and provide it that full path. And that's it. That's all it needs to generate the JUnit. The units are generated. Go back to the parent console and run the next step. We will do exactly that. We'll go back to the parent console, press any key to move forward. Review your JUnits. We go back to this location. Go to this, and you see this is the Kafka consumer test class that is generated. So let's verify it. Let's verify if there are any compilation errors, or does it look right to us. Okay, so yeah, right off the bat, no compilation errors. There is a test that got generated, and we have the test method generated which says received a message. Let's look at let's close this other things. Here, this is a consumer type. It says the method is received message, takes in a consumer as the input. This is the corresponding class that is generated. The invocation is here. So this is an instance of customer transaction consumer type 1 class. It is invoking the received message. It is passing a customer object to it, and when it passes, what it is expecting is that it is expecting that customer repo dot delete is called exactly once, and that's what is actually happening here. Customer repo dot delete is being called, and it is called only once, and that is what this assertion verification is also requires. What is the stubbing that it is doing? The stubbing that it is doing is when delete is called, do nothing. Why does it say that? You see, this delete is of return type void. There is really nothing we can actually check or verify based on the since it does not return anything. There is nothing to really verify. The only thing that we can do is check whether it is actually being called and how many times it is being called. So that is exactly what is done here, and that's what we do in this stubbing also. There is no when this is called return that. It's not like that. There is no possibility of that to stub here. So the only option we have is to do nothing when cust repo dot delete is called, because it returns a void. So now let's try to run this. You'll also notice that the input that is provided here is a very, very basic input. You can definitely change this to your customer object. You can create a customer object and you can supply it here. For our test case, it is just providing a legal parameter that fits the data type. Alright, depending on your functional test case, you can change this and add whatever is the most suitable for your case. Now let's try to run this and see whether it actually runs and how much of coverage that it will create. Say yes, launch the auto generated JUnits for customer transaction consumer type 1 test. Okay, so the tests are getting launched. The test is getting launched. Okay, so now it has run the test and it's a pass. It's passed the test. So here is the Jacoco coverage report. We will straight away go into the consumer and we will see how much is the coverage. The coverage that we got is 100%.